Okay, so myself, Attuluri Vamsi Kumar, I'm assistant professor in the Department of Medical Lab Technology, UIAHS, Chandigarh University. So in today's lecture, we'll discuss about types of anticoagulants as a part of our hematology subject. So let me share my PPT. So as I said, I'm Attuluri Vamsi Kumar. I belongs to Department of Medical Lab Technology, UIAHS. So in today's lecture, we'll discuss about anticoagulants. So coming to a brief overview of the syllabus and the content. So these are the networks and objectives of this subject, and these are the course outcomes. Upon finishing this lecture, you can able to understand what are the various types of anticoagulants we have, their uses, their mode of action, the selection of right anticoagulant for various blood tests. So this will help us to do the test precisely, accurately, with minimum errors and maintaining quality in the results of the tests. So for this purpose, we are using these anticoagulants. So currently we are going with the unit 1. In the unit 1, we have the following topics. We have definition, composition, functions of blood. And the second topic is anticoagulants. Anticoagulants, their uses, mode of action, and their merits and demerits. So straight to the notes. So before discussing about anticoagulants, we need to know some basics. Basics such as what is blood, components of blood, and a few things like the difference between whole blood, serum, and plasma. So coming to the whole blood means this is the blood containing all fluid and cellular portion. So the blood with cellular portion such as white blood cell, platelets, and red blood cells together is called as whole blood. So whole blood is used for the lab tests where there will be involvement of cells such as a cellular analysis like a total red blood cell count, total white blood cell count, differential count, cross matching. During blood donation, we need to match the recipient and donor's cells. So for this purpose, we will use this whole blood. So that is called the whole blood. But when we are discussing about whole blood, blood has a tendency to clot upon collecting blood in a vial. So this clotting action will cause the blood to clot, okay, and this will interfere in the results of analysis of any blood cells such as RBC or white blood cell. So in order to prevent the blood from clotting, we need to use certain chemicals or certain components, and they are called as anticoagulants. So upon adding these chemicals to the blood won't be clotted. It will stay in the liquid state so that we can do any cellular analysis of the blood. So that is why we are using anticoagulants to keep the blood in the cellular state. So apart from these anticoagulants, if we allow the blood to clot, then the blood will be separated into two portions. One will be the sedimentant, other one will be the supernatant. So upon clotting, whatever supernatant we are getting, this supernatant is called as serum. So serum is a uh, is a result of clotting of blood. So before discussing the serum, I need to tell what is clotting. So blood has a protein called fibrinogen, and this fibrinogen will be utilized for the clotting process. So whole fibrinogen will be utilized to make fibrin threads. So in the serum, there won't be any fibrinogen. So serum is a fibrinogen absence portion of the blood is called as serum. So and this serum is abundant in antibodies. So for any antibody testings, we will use the serum. Okay, that's why this rapid antibody testing department is called as a serology, because we are taking these antibodies which are present in the serum, and we will go for subject to many rapid car tests like rapid HIV, rapid hepatitis, malaria, syphilis, VDRL. All these tests are based on the serum. So serum is a product of clotted blood, whereas if you are not adding if you are adding anticoagulant, then the blood won't be clotted. Now if you go for centrifusing the blood, then we will again get a supernatant and a sediment. So that supernatant is called as plasma. So in case of plasma, since there is no involvement of clotting, the fibrinogen will be present in the plasma. So fibrinogen is present in the plasma, whereas in serum the fibrinogen is absent. So this is the major difference between a serum and plasma. So there are some tests where we need to study the plasma protein levels, such as albumin, fibrinogen, gamma interferons. So there are many proteins that are suspended in the plasma, and these protein analysis can only be achieved with the help of studying the plasma of the blood rather than serum. So there are instances where we need to use serum, and there are cases where we need to use the plasma. So depending upon the situation, we need to take the appropriate sample for lab testing. So this is all about whole blood, serum, and plasma. Then let us focus on various types of anticoagulants. So I hope this concept is clear. All these images are related to serum and plasma. By the way, so whenever there is a sediment and a supernatant, in between there will be a line, and this is called as Buffy Code. So here you can see this line is actually because of the molecular weight of the red blood cells and the white blood cells. Actually, red blood cells are heavier, so they will be sedimented first. Upon RBC sedimentation, there will be white blood cell sedimentation. And this particular layer is called as Buffy Code. If you want to go for analysis of any white blood cells, then we will take this Buffy Code for, we will take the smear of this Buffy Code and we will go for differential count of various white blood cells. So that is the significance of this Buffy Code. Then, yeah. So coming to the basic definition of anticoagulants. So anticoagulants are the substances that prevent coagulation or that prevents the clotting of blood. They are called as anticoagulants. So the antonym of anticoagulants will be clot activators. Clot activators will purposefully clot the blood. Upon adding these clot activators, the blood will accelerate in the clotting action. That's a different story. But now we are discussing about anticoagulants. And anticoagulants can be useful both in vivo and in vitro conditions. There is a case where the heart will get the coronary arteries in the heart will be blocked due to internal blood clotting, internal blood coagulation. Uh, in these cases, the patient will be kept under warfarin therapy. So warfarin is a oral anticoagulant. Upon giving this warfarin to the patient, the warfarin will it will thin the blood. The blood will become thin. That means the blood won't be clotted. Okay. So that is the idea behind warfarin therapy. And we are not going with the therapeutic approaches of these anticoagulants. We are only focusing on the in vitro or diagnostic applications of anticoagulants. That means what are the uses of these anticoagulants in the lab? If you want to do glucose test in the blood, what type of anticoagulant we are going to choose for a cellular analysis, for glucose or any metabolic products need to be analyzed by various types of anticoagulants, and those we are going to focus today. Okay, only the in vitro applications of anticoagulants will be discussed. Okay, and we are now going with therapeutic. So before discussing clotting, there is this mechanism called mechanism of coagulation. So this coagulation mechanism involves 13 clotting factors, and there are multiple clotting factors, and the one of the important clotting factors is clotting factor 4. Clotting factor 4 is calcium. So calcium plays a very important role in conversion of this fibrinogen to fibrin. So obviously there will be involvement of platelets. It is the platelets that are converting fibrinogen to fibrin with the help of these 13 clotting factors. So if we want to prevent clotting, we need to remove any one of these 13 clotting factors. Upon removing any one of these clotting factor, the blood won't clot. The coagulation cascade reactions will be halted since we have removed one of the ingredient that is necessary for going for the next step of this coagulation. So most of the anticoagulants will remove calcium from the blood, resulting in prevention of clotting of the blood. Okay, and this mechanism is called as chelation. Chelation means it is a process of removing calcium from the blood. That is called as chelation, and most of the anticoagulants will remove calcium, such as EDTA, ethylene diamine tetraesteric acid, is a chelative. It will remove the calcium from the blood, resulting in prevention of clotting, okay, or keeping the blood in the liquid state. Okay, this is all about the anticoagulants and their basics and their basic understanding. Then internationally, these okay, I will give the types of anticoagulants. We have many types of anticoagulants such as EDTA, ethylene diamine tetraesteric acid, double oxalate, sodium fluoride, heparin. Heparin is a natural anticoagulant. Then ACD, acid citrate dextrose, which is used an anticoagulant in the blood banking. Okay, so in the blood banking, the blood bags will be filled with this ACD and CPD. In this, the blood will be suspended, so that the blood can be stored in vivo condition, that means in vital condition. So the blood will be 75% of red blood cells will be alive for almost 45 days in the presence of this ACD or CPD anticoagulants. So that is the idea behind this ACD CPD. And there is one more a modified CPD called CPD-A. Okay, this is tetraphosphodextrose with adenine. Adenine will give further nutrient supply to the red blood cells to keep them alive for almost 45 to 46 days. So these are the various types of anticoagulants we have. So basically, these anticoagulants are broadly divided into two categories. One is calcium chelators and other one is non-calcium chelators. As I stated previously, calcium chelators are the chemicals that will remove calcium from the blood. Some of these examples include oxalates such as ammonium oxalate, potassium oxalate, and double oxalates. And most commonly used anticoagulant among these will be EDTA, ethylene diamine tetraesteric acid. Then non-calcium chelators are including heparin and warfarin. So heparin actually it activates or it triggers antithrombin 3 for the prevention of clotting. Okay, so antithrombin, as the name suggests, antithrombin it is an antagonist of thrombin activator. Okay, actually prothrombin will be converted to thrombin. Actually, there is a steps in a coagulation cascade reaction. Anyway, so heparin will try to accelerate the action of the antithrombin 3 in order to prevent the blood from clotting. Another oral anticoagulant that we discussed, which is warfarin. So warfarin, heparin are called as natural or oral anticoagulants, whereas calcium chelators are the in vitro anticoagulants. Okay. Yeah. So there is a specific color coding for various anticoagulants that we are using in blood in the labs. So these blood will be stored in various vials or small test tubes, and these test tube caps have various colors. Usually, the purple color is used for EDTA. So EDTA is suspended in a purple color, and these colors has been internationally standardized. Okay, so purple is used for EDTA. Oxalates are in gray colored vial tube. Then yellow is for coagulant suppression, clot activator. Red is non-additive. That means it's a reagent-free container. There won't be any anticoagulants in this. Okay, that is called red container. No additives are there. Then light blue is sodium citrate. So sodium citrate has light blue. So these are the various color schemes that has been internationally standardized for various anticoagulants. Yeah. So as I stated previously, anticoagulants are broadly categorized into two types: perinatal anticoagulants and oral anticoagulants, and anticoagulants that we are using in the in vitro conditions, such as in the laboratory. So moreover, since our program belongs to the medical lab technology, where we are focusing more on laboratory aspects of testing the human body fluids, hence we are only focusing on in vitro anticoagulants rather than touching the therapeutic anticoagulants. Therapeutic is for physicians and doctors. They only a doctor is authorized or licensed to treat the patient, whereas a lab technician is only authorized to diagnose the sample that is outside the body. Even we are not allowed to touch the patient, or we are not allowed to infuse any fluids into the patient body. That is against the code of conduct of medicine. So we are only supposed to do testings which the body fluid is outside the blood. Outside the body. Okay. Yeah. So this is all about the classification of anticoagulants and these things, color codings. Then let us discuss about individual anticoagulants. So starting with EDTA. As I stated, EDTA is called as ethylene diamine tetraesteric acid. This EDTA comes in two forms. One is dipotassium EDTA. That means there will be two molecules of potassium. And the other one is tetraacetic. There is the tetrasodium EDTA. In tetrasodium, there will be involvement of salt, whereas in the potassium, there will be involvement of potassium. That is the only difference between sodium and potassium EDTA. So the ideal concentration of EDTA will be 1% solution, which is dissolved in 0.5 ml of blood. Okay. So what are the uses of EDTA? EDTA is one of the most commonly used anticoagulant in the clinical laboratory. So it will keep the blood in fluid state almost for up to 4 hours upon collection of the blood. So it is used for testing CBC, complete blood count, such as hemoglobin estimation, TLC, total leukocyte count, total differential count, total differential leukocyte count, platelet count, red blood cell count, eosinophil count. All these things can be achieved with the help of this EDTA. Here you can see a small formula of action of this EDTA. So usually EDTA will remove calcium from the blood, resulting in calcium-free blood that keeps the blood in the fluid state. So this action of removing calcium is called as chelation. This we already studied. Then the second type of anticoagulant will be sodium citrate. So sodium citrate is the another commonly used anticoagulant. So this salt, the salt is used in trisodium citrate phenhydride 3.8% solution. So the uses of sodium citrate are this sodium citrate is used for especially estimation of ESR. Okay, erythrocyte sedimentation rate will be performed only in the presence of the sodium citrate EDTA. Sodium citrate anticoagulant. And this sodium citrate anticoagulant, the color of the vial of this anticoagulant will be sky blue. So sodium citrate is in sky blue vial. Okay. Then the third anticoagulant will be double oxalate. Oxalates are extensively used for estimation of CBC, PCV, and ESR. Okay. So oxalates, there are two types of oxalates. There are two types of double oxalates. One is ammonium oxalate solution and other one is sodium oxalate solution. So both ammonium and sodium oxalates can be used for coagulation studies of the blood. So various coagulation studies like bleeding time, clotting time, activated partial thromboplastin time, thrombin generation test, prothrombin time, all these coagulation profile tests can be actively studied in the presence of these double oxalates. Okay, double oxalates are very essential for studying coagulation disorders in the blood. Okay, then next one is heparin. As we already know that heparin is a natural anticoagulant which is secreted by the basophils. So there is a add-on advantage of heparin compared to all other anticoagulants. Since it's a natural anticoagulant, it won't get interfere with the laboratory reagents that we are using. So the accuracy of the results will be almost precise. There will be no error in the lab results if we are using heparin. But the backlog of heparin is it's very costly. It's very costly. Like one vial will cost around 70 to 80,000. So that's why heparin are not usually recommended in the labs unless and until the need is there. Okay. Some highly specific research and lab tests will be performed in the presence of this heparin. So heparin will be come in a vial called a green capped vial. So the color of this vial will be green. Okay. So heparin is used for studying lab tests such as G6PD deficiency, PK deficiency, osmotic fragility test, or even cellular distortion test will be studied by this heparin. Then, so last and final. So this is the complete overview of anticoagulants, and let us see a few questions. So which anticoagulant is most commonly used in hematology? Sodium citrate, EDTA, heparin, and warfarin. The answer will be EDTA. Then which one of the following anticoagulant acts by binding and sequestering calcium ions? That will be EDTA only. Okay, EDTA will remove calcium from the blood. The next question is, what is the primary use of sodium citrate? What is the primary usage? Sodium citrates are used for studying coagulation tests. So coagulation tests can be extensively studied with the help of this sodium citrates. Okay, and what does heparin work on, and how does heparin work as an anticoagulant? How does a heparin work as an anticoagulant? It accelerates the activity of the antithrombin 3. By accelerating the action of the antithrombin 3, the heparin will work as an anticoagulant. Okay. Then which anticoagulant is suitable for blood gas and pH? So blood gas and blood pH will be extensively studied with the help of lithium heparin, because lithium heparin will act as a buffer. Okay. So the answer will be lithium heparin. So what is the mechanism of action of sodium citrate? The mechanism of action of sodium citrate is sequestering or removing calcium ions from the blood. What could be the potential problem while using EDTA for coagulation studies? So it might chelate calcium needed for the coagulation. Actually, for coagulation, we need calcium for studying the clotting action of the blood. And if we are using EDTA, that test results won't be reliable. Okay. So which one of the following is preferred for anticoagulant for smear preparation. Usually, EDTA is the most commonly used anticoagulant for almost all types of lab tests that we are doing in the lab. Okay, so these are the references I have taken. These are the materials, and this is the textbook, and these are the further YouTube videos for this similar topic. So thank you very much. So let me take a quick overview of today's lecture. So in today's lecture, we discussed about anticoagulants. We know that anticoagulants will keep the blood in the liquid state, and there are various types of anticoagulants, and these anticoagulants coming with various colors. And these color codes are internationally standardized. And some of the few commonly used anticoagulants in the lab are EDTA, sodium citrate, double oxalates, heparin. Okay, so these are the few anticoagulants that we are using in lab. So this is all about anticoagulants. In the next lecture, we'll discuss about further topics in hematology. Thank you very much.